So what do you notice and what do you wonder about the function seen in the graph? What do you notice? What do you wonder? One thing you see. It's one thing that you see. Anything weird about this graph? They're in different places, like they're separated, right? Okay, so this is what we call that piecewise. We started talking about this last week. Piecewise function, because there's pieces of graphs, right? We got like straight lines, and then we got this little like swoop. This one's probably a quadratic, right? All right, so today what we're going to talk about is extending our knowledge of piecewise functions to include other function types. Okay, so last week, I know this looks like a mess. Last week we talked about how each line is going to be constrained to these domain restrictions. So like for instance, if we graph the blue one and we limit it, if I can draw, that'd be great. Okay, we limit it to just this little box right here. Okay, by this domain restriction. So we go, when x is -1, we're going to look all the way to the left. Okay. Now for the red line, we have from x is -1 to x is +1. So all that junk in between. And then on the last one, we have x is greater than 1. So we're going to include this picture. Okay. If we take all three of those pieces and we put them all together, ta-da, we get this finalized picture. Okay. So that was the foundation of piecewise functions, right? So again, domain restrictions. One thing I do want to talk about is this underneath line. That means that x is less than or equal to -1. Okay. If it does not have a line underneath, then this means that x is greater than -1, but less than 1. Okay, so x is in between -1 and 1. Okay, if it has a line underneath, that means that it's going to be included. If it doesn't have a line underneath, it's not going to be included. And there will be a difference on that. All right, so we're going to write the equation for piecewise function. Okay, so these are all kind of weird. They all are different lines though. So we're going to start with this guy over here. Well, where does this guy start from? -3, and he goes to the left, right? So we're going to say when x is less than 3. Now, since it has a black dot, like it's filled in, we're going to put a line underneath that domain restriction. Okay. Last week, we learned about how we're going to write this as f of x, and we use a little squirrely bracket, right? Okay, so now we're going to actually write the equation. Well, this is a horizontal line at y equals -2. It's not changing. So our slope is 0, and our y-intercept, if we extended this, would be -2, right? So this function is going to just be -2. If it is a horizontal line, it's just whatever that y value is. Okay. On the next one, we have this line right here. Well, where does it start? X equals -3. And where does it finish? X equals 0. So we're going to say x is in between -3 and 0. Now notice how these are open dots. So we're not going to put lines underneath. Okay, so now we're going to write the equation. Now this is a straight line. So you have to remember that back in the day when you were talking about algebra 1, when you talk about a straight line, this is the formula for it. We find the slope and we find the y-intercept. Well, what's our y-intercept? 4, okay? And what is our slope? Well, we're going to start at this point and we're going to go to the next point. We see that if we go up 1 and to the left 1, that's going to be our slope. So we know that it's going to be negative. So we're going to have negative 1x plus 4. I'm going to go through that thought process one more time. So I needed to find my y-intercept, which was 4. My slope came from rise over run. So if I just took any point on this line, and I would say I would go to the right 1 and down 1. So that's to the right 1 and down 1. So that's negative 1 over 1, which is negative 1. That's where we got this equation from. Okay, can you try that last one, trying to write the equation for that? Can you find the domain restriction, and then can you write the equation? Take a moment, try to think about it. We'll talk about it in just a second. So we see our domain restriction is from 0 to positive infinity. So we're going to say x is greater than or equal to 0. The reason why I'm going to put that line underneath is because it's a filled in dot. And now I'm going to write the equation. So remember, we're going to use y equals mx plus b, where our y-intercept is 0. And then our slope is up 1 over 1. So we see that it's in the positive direction. That's going to be 1x. So if we write this out as a regular equation, we'll just have x, because we're going to leave off that 0, right? And ta-da! If you're ever unsure of whether or not you graph this correctly, you can plug it into Desmo. So let's talk through this one. Let's talk through the red line first. Unfortunately, these don't have such a clear thing for the black, like the closed dot versus open dot. So you kind of go with whatever the color is overlying. Okay, so we're going to talk about the red one first. We're going to say f of x. We're going to say squirrely little bracket. And where is our domain restriction? Well, it goes from -3 to -1. So we're going to list that out. -3 to -1. Okay. On the left-hand side, we're going to put a line underneath because it does look like it's filled in. They didn't really like clarify it on this one, but that's okay. Now let's write the equation for this. If we extended this line completely, we see that it's going to cross out y equals 0. We also see that the slope is going to be up 1 over 1. So the equation for this one is going to be y equals mx plus b, which is going to be x plus 0. Okay. On the next one, we see that it's a horizontal line. And if we extend it, it crosses it at -1. So this is going to be y equals -1. And that's going to happen between -1 to 0. -1 to 0. Now we see that this blue is laying over this red. So we're going to say that that does include on that left-hand side. Can you write the equation for the green line or teal line, whatever you want to call this? You write the equation for the teal line. So we see that it starts from 0 to 2. Okay, so we're going to say from 0 to 2. And we also see that it kind of overlays on that blue. So we're going to say that that's included. Okay, again, kind of hard to see on this one, but it's okay. Now we're going to write the equation. Well, it crosses the y-axis at -1. Okay, so the y equals mx plus b. B is going to be -1. Our slope is going to be up 1 over 1. So we see that's positive. That's going to be 1x. Our equation is going to be x minus 1. All right, the last one, got this black line. It goes from 2 to 3. So we're going to say from 2 to 3. And it overlays on this one. And this is the only one that it touches. So we're going to say that's included on that one. Now here's the hard part, writing the equation for this one. Okay, if we extend this line, where's it going to cross the y-axis? What number is going to be right here? Somebody said it, 3. Okay, so when we want to find the slope, we're going to start from this point and go over 1, down 1. So that means that our slope is going to be -x, and our y-intercept is +3. So on this one, we are going to start with the red one first, okay? You do have to have some type of knowledge of quadratics. Hopefully you remember a little bit from that. So we're going to just write our f of x. We're going to write a little squirrely bracket. And we see that it goes from -infinity and it stops right here at 1. So we're going to say from -infinity. Oh, I'm sorry. There's another way to write this. X is less than +1. So x is less, oops. X is less than 1. There we go. I need a nap or more caffeine, one of the two. All right, so now we're going to write the equation for this quadratic. Okay, so we see that it's a quadratic. There's a couple different ways you can write this. I personally like to use vertex form. Vertex form looks like this. Okay, so h is going to come from the x value, and k is going to come from the y value of the vertex. Vertex is the lowest or highest point. So we see that it's the lowest. So we're going to take this point, which is -1, -3, and we're going to plug it into this equation. So we're going to get x plus 1 squared minus 3. Now, one thing to keep in mind with this is that sometimes there's an a out front. So you kind of have to check and make sure that that equation works. So I'm just going to pick another point and see if I can plug in and it work. For instance, if we had 0, -2, when we plugged it into this equation, that would give me -2, so it does work. But sometimes there's an a value chilling out front. Okay, now we're going to write the equation for this blue line. So that's when x is greater than 1. X is greater than 1. And this blue dot right here shows us that it's going to also be equal to. If we extended this line, okay, we're trying to see where it crosses the x-axis. Well, we can see that the slope is over 1 and then down 2. So the slope for this one is going to be up 2 over 1. So it's going to cross the x-axis at y equals 3. And our slope was -2x. So there's our equation. All right, so it says identify the types of functions in the piecewise graph. So we're just naming, right? Okay, so right here, we have this equation. What type of function is it? It says it right here in the equation. Log. Okay, so we have a log function. Okay, we also have this equation right here, and it tells us what the type that is. That's a rational function. Okay, remember rational functions are going to have an x in the denominator. Okay, it's going to be like a fraction. Okay. And then this right here, this could be a quadratic. Oh, I apologize. It's just 2. It's the rational function. This is part of the rational function as well. All right, so we're going to state the end behavior. So where does the function actually end up? So as we move to the right, as our x values are moving to the right, what's happening to our y values? Where are they getting closer and closer to? Not negative infinity. Where are they getting closer to? There's a horizontal asymptote at 0, right? So y is approaching 0. Okay, as x goes to, and this graph stops at 0. So as x is approaching 0 from the right-hand side, where are our y values going? Negative infinity. One thing you do need to pay attention to is your domain restriction. Okay, because this graph doesn't go past 0.